Math learners, we have already discussed the introduction, the overview, and the terms related about circles. We also have discussed the relationship among the chords and arcs. For today's lesson, we're going to discuss the relationship of arcs and the central angles. So, sit back, relax, and finish this video. But before anything else, hit the subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners! Welcome to another session here in Math Learning with Sir Ash. This is still your free access math teacher Ash, and today we're going to discuss the most essential learning competency-based lesson for quarter 2 of the grade 10 mathematics, which is all about arcs and central angles. In this lesson, you will know the relationship of arcs and central angles. Question is, what is an arc? If you could still remember, an arc is part of the circle's circumference, while central angles are angles in the circle in which the vertex of these angles is the center of the circle. Easy, right? So before diving in to the solving part, let's talk first about the relationship of the arcs and central angles. The first thing you should know is that there are at least 3 relationships among arcs and central angles. The first thing is that the measurement of the intercepted arc is equal to the measurement of the central angle. Of course, if you have a central angle, which is this one, and this is 45 degrees in measurement, basically the intercepted arc is also 45 degrees. That is the basic concept of the first relationship. The second relationship is that the diameter, as we know, is a straight angle in which it divides the circle into 2 equal parts, meaning that the diameter will have an intercepted arc that is a semicircle. Easy, right? Now, let's go to the third relationship, and that is what we call as the arc addition postulate. Now, what is this arc addition postulate? Basically, from the word itself, arc addition, when you add all the arcs in a given circle, you will have the total measurement of the circle as 360 degrees. So basically, talking about the relationship of arcs and central angles, it is very easy. Now, let's put it into some problems. Okay, math learners, we have here some sample problems about how to solve certain problems involving the relationship of the arcs and the central angles. So we have here our first figure, the circle F. Now, in this figure, we are owed to find the measurement of angle BFD, angle AFE, the arc DE, and the arc DEA. Okay, so first things first, let's try to solve angle BFD. This is the BFD. Okay, so as you can see in this figure, it has 60. We don't know what this is, and this is BFD. So basically, we need to know angle BFC first in order for us to know the angle BFD. But how do we get this right? Now, just observe this given figure. As you can see, this is a diameter. If that is a diameter, then this arc, this AD arc, or arc AD, is equal to 180. Now, since this is 180, 60 and 45 is already given. Now, if you try to add 60 plus 45, that will give you 105. Now, remember this is 180. What number is needed for this 105 to become 180? Of course, that is 75. So, therefore, this angle is equal to 75 degrees. Now, having said that, our BFD as an angle is already complete. So basically, what we need to do is we just add 75 and 60 and we will have 135 degrees. Easy, right? Now, let us go to angle AFE. AFE. Okay, so we have here angle AFE. So this is the one, okay? AFE. And of course, this line segment is a diameter. And since we already have the 75, we already have the 45. So we just need some numbers or some number in order for this group to become 180. Now, 75 plus 45, what is the answer of that? 75 plus 45, that will give you 120 degrees. Right? So, by getting 120 degrees, what is needed in order for 120 to become 180? And the answer is, very good, that is 60 degrees. So, therefore, this is 60 degrees. Easy, right? So, now, we will have the measurement of arc DE, and this is the one. Remember in our first relationship that the measurement of the central angle is equal to the measurement of the intercepted arc. Arc DE is the intercepted arc of angle DFE. So, by knowing this angle, you will have your angle DE. Of course, this is 180, right? Since that is 180, and you already have the 60 here, of course, 180 minus 60, you will have 120. Therefore, if this angle is 120, then arc DE is also 120 degrees. Easy, right? Now, let us go to the last problem for this figure. We have the measurement DEA, arc DEA. That is DEA. Of course, because of this line, this diameter, this line segment, this is a semicircle. And remember, the semicircle is equal to half of the circle's total measurement, which is 360. And that is half of that, 180 degrees. Easy, right? So we have already answered our first figure. Now, let us go to our second figure, the circle J. Okay, in circle J, there is only one problem. What is the value of x? Now, where is our x here? This is the angle HJI. Okay, so since this is a whole circle, that is basically 360 degrees. You just subtract that to the sum of 175 and 125. So you just add 175 plus 125, then that will give you 360 minus 300, giving you the answer 60 degrees. So therefore, this is 60. So if this is 60, of course, 60 plus 175 plus 125, you will get the whole measurement of the circle, and that is 360 degrees. Easy, right? And now, let us go to our third figure, which is this one, the circle O. Okay, so in this figure, there are two problems. We have the measurement of RKN and the measurement of the angle LON. So, of course, K and N is here. So, if that is the arc, this is the one, or it could be this one. Basically, you don't need to solve that one, and that is already 180 degrees because of the fact that KN, RKN is a semicircle. Easy, right? Now, let us go to the measurement of angle LON. So, angle LON. So, this is the one. Okay. So, that is the measurement that we need to get. Now, since this is a right angle, MON, that is already 90 degrees. And LOM is given as 20 degrees. So, you just add the 90 degrees and the 20 degrees to have the angle LOM. And 90 plus 20, that is 110 degrees. Easy, right? So, now, let us go to our fourth example. This is circle T. We have here three problems for this figure. So, QTR. So, angle, the measurement of angle QTR, that is QTR. Okay, this is the X. QTP, the angle QTP, QTP, the 4X minus 2. And the RQRS. So, this is the one. Okay. So, basically, QRS is the combination of this angle and this angle. So, this is the total for the QRS. Okay. So, how do we get this one? Of course, because of this line segment PS, which is the diameter, the total measurement when you add 4x minus 2x and 77 is equal to, very good, 180 degrees. So, we need to get first the value of our x from this given. So, what we do is, we get 4x minus 2 plus x plus 77 is equal to 180. So, by doing so, we have 5x and then negative 2 plus 77, that will give us positive 75. So, if we transpose our 75, we will have 5x is equal to 180 minus 75, and that will give us 5x is equal to 105. Now, if you divide 105 by 5, basically, you will have a value of 21. So, therefore, this x here is 21 degrees. So, this is QTR. So, that is already our first answer. Easy, right? Now, since we have the 21 here, we also have the 77 here, we can answer this angle, which is the arc QRS, and that is 21 plus 77. So, 21 plus 77, that will give us 98 degrees. Now, we have the QTP, which is this one. Basically, you can do this in two ways. You can substitute the value of x, or you can just subtract the 98 to the 180 degrees, and that will give you 82 degrees. The other way is by using this expression. You have already solved the value of your x, that is 21. So, 21 times 4, that is 84. 84 minus 2, and that is 82. Easy, right? So, now, let us go to our final example, which is the circle Y. Okay, in this circle Y, as you can see, we have the central angle, and we also have our intercepted arc. So, now the question is, what is the measurement of arc VW? This is the one. And what is the measurement of angle UYP? So, this is unknown, and this is also the one that is being asked. Okay. So, since the relationship is that the central angle is equal to the intercepted arc, basically, what you can do is you can equate the 9x minus 15 to the 7x plus 5. By transposing the like terms, 7x will go here. That will become 9x minus 7x. And this 15 will go to the right side. So, minus 15 will become positive 15. So, that is 15 plus 5. Giving you 2x, because you subtract 9x minus 7x. And 15 plus 5, that is 20. If you divide both sides by 2, then you have a value of x that is equal to 10. However, this 10 is not an answer, but an instrument to get our value for this arc. So, if this is 10, that is 7 times 10, 70. 70 plus 5, and that will give us 75. Of course, if this is 75 degrees, this is also 75 degrees. And as you can see, this is a relationship of intersecting lines in which it forms vertical angles. If you could still remember your lessons about lines and the relationship of lines, if these are two lines that intersect with each other, the angle that is formed here is also equal to this one. The angle that is formed here is also equal to this one. And that relationship is what we call the vertical angles. Vertical angles are always congruent. Easy, right? So basically, if measurement VW, arc VW is 75, of course, the measurement of angle VYW is also 75. If that's the case, then this angle is also 75 degrees. So you have answered your two problems. So we have answered all of our given sample problems in this session. I hope you have got that, my dear math learners. If you don't, then just put it in our comment section below. Now, this is the time that I will challenge you whether you have understood our topic, and here it is. Okay, math learners, I hope you have a wonderful time in our session for today. This is still your free access math teacher, Ash. And always remember, it is fun to learn mathematics if we are together learning. Thank you for subscribing, sharing this to your friends, classmates, and schoolmates, as well as liking this. Take care, God bless, and keep safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.